Good evening, all. I would like to welcome you all for the 5th day of AICT Training and Learning Academy sponsored 2-week faculty development program on power electronics application to renewable energy systems, electric vehicles, and intelligent control. Offline session will start by next week, 17/10/22. All are invited to attend the offline session, and we are going for an industrial visit on the first day to EV Nexus Private Limited, Nanganallur, an EV industry. The session will be followed by Ms. A. Sasikala, co-coordinator of this FDP. Will read the short bio of today's distinguished speaker, Mr.Kavin KS, Managing Director and R&D Engineer of EV Technologies Private Limited. Ma'am, please continue.
Good evening to all. Today's speaker is KS Kavin, Managing Director of EV Technology since 2015. He did his BE in CSI Institute of Technology, ME in Power Electronics and Drives from Shanmugha College of Engineering, Pudukkottai, then MBA from Madras University. He is presently doing MSc in Alagappa Chettiar Karakudi and also PhD in Anna University. He is expert in designing, testing, installation, service and maintenance of AC and DC drives using DSP controller, IGBT, SCR, MOSFET based power inverters and converters. He is also having hardware control of AC and DC drives using DSP controllers. He is also having a wide knowledge in testing side. He has published 22 journal papers in international journals and 10 conference papers and won many best paper awards. He has special skills. He has wide knowledge in MATLAB embedded system. He has conducted many conferences and workshops in various colleges and many training programs to students as well as teaching and non-teaching faculties. He is also guiding students to do innovative projects. He has conducted many guest lectures in inverters, embedded system, MATLAB and PCB design and workshops. Welcome, sir. Your session, sir, starts now, sir.
Thank you so much, ma'am.
Thank you, sir.
So, good evening to all. So, today I will discuss about AI for SOC estimation in EV batteries. So, before starting the technical section, I will tell some basics. So, why we have to go for SOC estimation and artificial intelligence. So in the conventional system for vehicles, we are using petrol or diesel based fuels. So because of this petrol as well as diesel, we are getting huge amount as well as pollutions. Pollution is the main problem. In recent days, cost also is a big problem. So to overcome these issues, we are going to use electric vehicle. So similarly, for power generation, we are using thermal power plant as well as nuclear power plant. These power plants also produces a huge amount of pollution as well as it needs a huge amount of investment and maintenance cost. To overcome these issues, we have to go with renewable energy resources. So the applications of renewable energy resources are, first one is EV, electric vehicle. And another one, we can go with the smart grid, microgrid, as well as normal single-phase grid connected systems. So in this electric vehicle application, as well as grid connected system applications, we can use PV as well as wind energy conversion system. Here we have to store the energy. So during daytime, we can get the power from PV system. So at that time, we have to store the energy in battery. So we can store the energy in battery. But here the important things, we have to measure the SOC, state of charge. So how much percentage charge is there? So with respect to this SOC only, we can make the battery mode of operation, either charging mode as well as discharging mode. So this is very important parameter in battery. So to monitor the SOC, in this section, I will explain about the artificial intelligence techniques. So before that, I will explain the every basics. So this is the first vehicle. So all of them see two buffaloes are there. These are two tires. That means fuels, and the two tires are there. One driver is there. The drawback of the vehicle, it cannot carry much amount of load, and the speed of the this system is also very less. That's why we are moving to vehicle, normal internal combustion vehicle. In IC based vehicle, the fuel is petrol as well as diesel. So already I have told, if you use this petrol as well as diesel, first one cost problem, and the second one is the pollution problem. So we are moving to next system. So first I will explain about one good topic, solar based grid-tied system. So to overcome the normal conventional fuels, we have to go with the renewable system. In the renewable energy, so many energies are there, but among these, the best two are PV and wind. The advantage of the PV system, cost is very less, but space requirement is high. But in wind energy conversion system, cost investment is very high, but we require only very less amount of space. That is enough for wind energy conversion system. And another one advantage of the PV system, if temperature increases means definitely we will get good voltage, good power from the PV system. In wind energy conversion system, if wind speed increase means we will get the energy. But the drawback of the wind energy conversion system, we cannot expect wind in all areas. So especially we can get the high amount of wind energy conversion system in our Kanyakumari district. So, but in nearby districts, it's not possible to implement the wind energy conversion system. But we can use PV system. So photovoltaic system is the best one. So how we are getting the power from PV system? So I will explain the basics of the PV panel. So actually the combination of atoms is called cells. So atoms means it consists of protons, electrons, and neutral charge neutrons. So the combination of cells is called, so first one is group of atoms is called cells. Then group of cells is called array. Then group of array is called panel as well as module. So in India, under short circuit condition, from PV system, we will get 12 volt only. So open circuit voltage around 22.6 or 28.7 volt up to we will get it. But under short circuit condition, so rated voltage from the PV system, we will get 12 volt. The power may be 10 watts, 20 watts, 50 watts, 100 watts, 250 watts or 1000 watts. The voltage will come 12 volt. But we know the single phase AC output voltage, that is 230 volt AC. So if you want 230 volt AC means we have to maintain 300 volt DC. So if you maintain 300 volt DC, then only we can give 230 volt AC to the grid as well as load. So here we maintain 300 volt DC. So in order to get 300 volt DC, we have to connect 25 number of solar panel in series. So 25 into 12, we will get 300 voltage. Here also some problem is there. If temperature as well as intensity falls down means we cannot get this voltage also. So around 30 number of solar panel we have to connect in series. Then only we will get 300 voltage. So then think about the cost as well as space requirement. Actually, on 10 watts panel, so around it will come 550 rupees. That means the cost of 1 watt is 55 rupees it will come. But if you go with 1000 watt solar panel or 250 watts solar panel, it will come only 26,000 rupees. That means 1000 watts panel cost is 26,000 rupees only. Here, 1 wattage amount is just 26 rupees. So here I am suggesting you can connect number of solar panels in parallel. So we have to reduce the number of parallel series connection. So for that we are going to use one converter that is chopper, DC to DC converter. So from PV system, we will get variable output voltage and we will get very less amount of voltage. So here that means we have to do two works. First one, we have to maintain constant DC link voltage, and another one, we have to step up the output voltage. So two purposes are there. The boost converter, its voltage gain is 1:1.5 only. 1:1.5. So if you give almost 200 voltage to the boost converter, we will get 300 volt DC. So compared to the conventional topologies, here we can reduce the number of solar panel. We can reduce the number of solar panel. For example, instead of 30 number of solar panels, now 20 panels are enough. So with this step-up converter, we can reduce the number of solar panels. The boost converter is very basic one. So many advanced converters are there. So during offline mode, I will come to college and I will explain all the different types of non-isolated high gain DC to DC converters. So here I will go with the normal conventional boost converter. So the first work, the boost converter will increase the output voltage. Then second one, with some MPPT algorithm or closed loop optimization technique, we have to extract maximum power as well as we have to maintain constant DC link voltage to the inverter system. So how the PV panel converts the sunlight into electricity means, so the structure wise, the PV system having aluminum as well as silicon dioxide, SiO2. SiO2 means we know sand, that is insulator, and the aluminum is the conductor. So combination of insulator plus conductor is called, we know, semiconductor. When temperature falls in the solar panel, what will happen means heat will increase. So due to this heat, electrons will flow. We know flow of electron is called current, that is I. Silicon dioxide means insulator, that means that is resistance, R. So when the current is flowing through the resistor, we know Ohm's law, V is equal to I into R. This is the way solar panel converts the sunlight into electricity. So this solar panel depends on two cases. First one is temperature and second one is intensity or irradiation. So temperature is the heat, intensity or irradiation is the brightness variation. So two parameters can change the solar panel output. Next one, why we have to go to the MPPT algorithm, maximum power point tracking algorithm. Let us take 1000 watts solar panel. If you provide this 1000 watts solar output to one load, means the load can utilize only 26% of the power. That means only you can provide 260 watts to the load. So remaining all are losses. So efficiency is very, very less. So in order to overcome these issues, we have to go for MPPT algorithm, maximum power point tracking algorithm. So here we can use two techniques to control the boost converter, that means DC to DC converter. First one is the MPPT algorithm. Second one is the closed loop controller. So algorithm and controller, you can keep it in mind. So in MPPT algorithm, you can track maximum power. That means we can maintain constant output power, but in output voltage, we can expect, definitely we can expect the oscillations. But in closed loop controller, if you use PI controller or Fuzzy controller or any other advanced controller, we can expect ripples in the oscillations in the output power, but in the DC output voltage, DC link output voltage, we can expect constant DC link voltage. That is the difference between the MPPT algorithm as well as optimization technique or closed loop controller. MPPT algorithm can track maximum power. Closed loop controller will maintain constant DC link voltage. So for standalone load means normal load. For this standalone load, we can use MPPT techniques. That is the best one. If you go with electric vehicle or single phase grid connected system, that means you are connecting AC load, means closed loop technique is best one. Closed loop controller is best one. because if your DC link voltage having oscillation means definitely it will create total harmonic distortions in the inverter output. It will increase the TST. So the best solution closed loop controller is we can use for single phase grid connected system. Anyhow, this MPPT as well as closed loop control is used to control the boost converter output. So the first one from PV system we will get variable output voltage with the help of boost converter and the MPPT algorithm or closed loop controller. You can maintain constant output voltage or constant output power to the single phase inverter. Now our single phase inverter will convert the DC voltage into AC voltage with the help of sinusoidal pulse width modulation 180-degree PWM technique, because this is single phase voltage source inverter. So the angle difference will come 360-degree divided by 2 lakh, so it will come 180-degree. So the mode of operation of the single phase voltage source inverter is 180-degree. But the output of the inverter will come square wave. But for grid, we have to provide sinusoidal AC output voltage. So the LC filter will reduce the harmonics. That means it will make the square wave into sinusoidal wave. Then we can provide the sinusoidal wave to the single phase grid. In power electronics subject, we have studied only this parameter. We have to convert the square wave into sinusoidal wave and we can do to the load. If we inject the power into the grid, here we have to achieve grid synchronization. Without grid synchronization, it's not possible to maintain reactive power compensation. So this is additional another section. So we have to compare the reference real power and the reference reactive power with respect to the actual real power and the actual reactive power. So what is real power? Product of V into I cos pi, VI cos pi. That is the original power to the load. Next one is the reactive power. That means losses. So here losses will be 0. Reference losses will be 0. Actual power depends on the solar panel. So if you use 1000 watts solar panel means here we can maintain 900 watts to the load. So the reference power is 900 watts. That means we can track 90% efficiency with the help of the MPPT algorithm. Next we can get the actual power. So from this reference power and the actual power we will get error. That error, let us take. So I will explain the PI control, work of the PI controller very clearly. If you want to generate a PWM pulse, we need 2 signals. First one is the reference signal and another one is the carrier signal. So in PWM techniques, the first PWM is single pulse width modulation. Second one is multiple pulse width modulation. And the third one is the sinusoidal pulse width modulation. Here we have to convert DC into AC. So we have to use sinusoidal pulse width modulation. So the carrier signal amplitude will be 1. The amplitude of the carrier signal is just 1 volt. But if we compare the reference power and the actual power, for example, our 900 watts is the reference power, 800 watts may be actual power. What is the error? 100 watts will come. So 100 will come. So if we compare these 100 with 1, it is not possible to get the PWM pulse. So in order to make 100 into less than 1, we have to use one controller, that is PI controller. So through proportional gain and integral gain, Kp and Ki, we can fix some gain. For example, error is 100, we have to make this error into 0.1. For example, I am telling. So you can assign 100 into Kp into Ki. For example, Kp I am substituting 0.1. So it will come 10. Then again I am substituting 0.01 as Ki. So definitely it will come almost 0.1. So this is the way we can set the Kp as well as Ki value, that is trial and error method. So we can convert the high value of error into less than 1. Then we can compare this reference signal into carrier signal. So we will get the PWM pulse. So this is the use of PI controller here. So the reference and carrier signal will provide PWM pulse. If you provide the PWM pulses to the inverter, we will get AC output voltage. So this is the way we can convert the DC into AC and we can provide to the single phase grid. In this system, I didn't connect any battery. That means energy storage system. Then what are the drawbacks of the system? During daytime, we can provide PV power into grid. During night time, this system will not work because there is no energy storage system. There is no battery or supercapacitor or any electromagnetic storage devices. So this system wants battery. So without the battery, this is not good. It's not a good system. So this is the solar panel equivalent circuit. When sunlight falls in the solar panel, current will increase. So already I have told. So silicon dioxide, that is resistance only, series resistance and parallel resistance. This will vary, depends on the NS and NP. So when temperature increases, the electrons will flow to into the resistance. So here we will get the voltage. But the drawback, these curves, PV and IV curve, so it will not be a constant. If temperature increase means this will change. So to overcome the issues, we have to use boost converter. So this is the circuit of the boost converter. Already all of them know, but once again I will explain it. If you provide the DC voltage to the inductor, that means next to the DC source, if we connect inductor, this will make our input current as continuous conduction mode. So in solid state drives, we have studied about two conduction mode. First one is continuous conduction mode and discontinuous conduction mode. The boost converter comes under continuous conduction mode. The reason, next to the DC source, inductor is there, electromagnetic storage device. So it will make the input current as continuous. But check the output side, there is no inductor. So in the boost converter, the advantage is input current is continuous, but output current is discontinuous. So this is the function of the inductor. And also, kinetic energy of the inductor is, we know, half Li square or half Mv square. That's why I told the voltage gain of the boost converter is 1:1.5 only. If you provide 100 volt, it can give 150 volt. That's all. Then what is the function of diode means? While connecting into the load, we have to provide the current from source to load only. If any returns from load to source means what will happen? The device will fail and the DC source also will fail. So that's why here we have connected one diode. So we know the working of the diode. It can allow current in only forward conduction mode. That means forward biasing mode. In reverse biasing mode, the diode will not work. So it will block the return current or return voltage. That means dV by dt protection. So this diode will provide change in voltage protection. That means dV by dt protection. We can tell it as snubber protection. So this is the purpose of the diode. Then what is the use of capacitor means? It will provide two functions. First one, it can store the output voltage from the switch. And the second one, it can reduce the ripple contents. Because capacitor will work during positive cycle, it will be in charging condition. During negative cycle, it will be in discharging condition. In the chopper output, the negative cycle will not come. So always it will be in charging. So we will get almost constant DC link voltage. So this is the use of normal boost converter. This is the structure of the boost converter. Once again, I will explain it. Next to the DC source, one inductor is there. So this is continuous conduction mode. One diode is there, it will provide dV by dt protection. That means snubber protection. The switch is used to vary the output voltage. That means already I have told, if you give 100 volt, we can vary up to 150 volt. With this switch and duty cycle, alpha, T1 divided by T. With this duty cycle variation, we can change the output voltage of the converter. So the switch is used to control the output voltage. So the advantage of the boost converter, input current is continuous, but output current is discontinuous. Voltage gain is very, very less. Then ripple factor will be very, very high. That means the amount of ripples in the output voltage is very high. So next we have to control the converter. So for that, I have taken the same basic algorithm. If we know the basic, then only we can go for advanced algorithms. So without knowing the basics, it's not used for going to advanced. So first I will explain the P&O algorithm. Perturb and observe MPPT algorithm. It comes under maximum power point tracking algorithm. This MPPT algorithm only it can use for low power application, 1000 watts maximum, that's all. If you go with more than 1000 watts, you cannot extract maximum power from the PV system. I will tell you the reason also. So this is the flow chart for the P&O algorithm. Initially, we have to measure the solar panel voltage V of X and solar panel current I of X. PV current, PV voltage. For every 10 millisecond, why here I am telling 10 millisecond means we know the AC supply, positive cycle having 10 millisecond and negative cycle having 10 millisecond, that's why 20 millisecond. DC means only positive cycle, so we have to allot the time as 10 millisecond. So for every 10 millisecond, we have to check the voltage as well as current. So 10 millisecond back, we have measured some voltage and current. That is, if you get the product of voltage and current, that is reference power. And current value. So after 10 millisecond, we are getting some voltage and current. If we multiply these two, we will get actual power of the system. That means 10 millisecond back, how much power we got from the PV panel. And just now we are getting how much power from the PV system. So if we compare these two, if your error is 0, we have to maintain same duty cycle to the converter. That means 0.5%. So initially we will compare 1 volt carrier signal with 0.5 reference signal. So we will get 50% on and 50% off. The formula for duty cycle alpha is equal to T on by T. So 0.5 divided by 1 into 100, 50%. So you can keep the same duty cycle. If your power error comes means we have to check whether it is in positive or negative. If it is positive means you have to increase the duty cycle. Otherwise, we have to decrease the duty cycle. If we increase the duty cycle, we can change the converter output voltage to the load. Again, we have to check the power. If power error is 0, then the duty cycle will be same. For example, 0.6, 60%. Again, if error is there, once again, we have to increase the duty cycle 0.6, 0.7, 0.8, 0.9. Like the way duty cycle will increase or decrease. So if we increase or decrease regularly, what will happen? Switching losses will increase. This is the first drawback of the P&O algorithm. Because it's not controlling the reference signal. It's directly adjusting the duty cycle. And also here you can see there is no memory units. There is no rules. It's like a trial and error method only. Just it will check the output power and the reference power. It will adjust the converter output parameter. So the drawback of the system, first one is the switching loss. And the second one, it's not suitable for medium power as well as high power application. It's a maximum limit. Practically, I am telling 1000 watts. If you go more than 1000 watts, it will give 60% or 70% efficiency only. So to reduce the problem, we have to go with intelligent controllers. That is intelligent MPPT techniques as well as intelligent control technique. So this is basic P&O algorithm. If you go with closed loop technique means PI controller is the basic one. So in PI controller also same problem we can get. So to overcome these issues only, we are moving to intelligent control technique. That is first algorithm is fuzzy logic MPPT algorithm. So while I am studying my MTech, I don't know about the fuzzy logic, how it is implemented to get the how to track maximum power from the PV system. In theory, I have studied fuzzy logic is okay. It can provide more than 90% efficiency. It will track, but I don't know. Practically, I don't know. But after developing so many of the PhD works and BTech, MTech projects, so I have studied about, I have learned practically about the fuzzy logic technique. So now I will explain about the fuzzy logic algorithm. So fuzzy is the intelligent technique. Why it is intelligent technique? So fuzzy logic, artificial neural network or neuro-fuzzy logic controller techniques are, we can tell it as intelligent controller. So intelligent means brain will come. That means memory unit will come. It can store the data. It can store the data. That's why we can tell it as intelligent techniques, intelligent controller. That is the reason. So if the technique is having memory means two type of error will come. First one is error and the second one is change in error. So error means present value, reference power and actual power, I will get one error. This is error. What is change in error means 10 milliseconds back some values we got now. Reference power as well as actual power. If we compare these values, this will be a change in error. So in a normal MPPT algorithm, we cannot create this kind of error as well as change in error. The reason it does not having memory, that's all. But the fuzzy logic or ANN or ANF is having memory unit, so it can provide error as well as change in error. So compared to the existing techniques, definitely we can reduce the ripple contents in the output voltage. So this is the general step of the fuzzy logic algorithm. So how to implement the fuzzy logic algorithm means, let us take one solar panel, 1000 watts solar panel. Here we have to use two sensors. First one is Hall effect voltage sensor and another one Hall effect current sensor. So if you use Hall effect voltage as well as current sensor, you will get almost exact value of the PV panel output voltage or PV panel current. But if you use normal potential divider circuit or normal current transformer CT, it will not provide effective value. So the best one is Hall effect voltage sensor and Hall effect current sensor. So we can measure the PV panel voltage as well as PV panel current, and we can do this voltage and current to the one of the digital signal processor or any of the FPGA controller, field programmable gate array, or DSP controller, digital signal peripheral interface controller, DSP controller. You can choose any of the controller. That is not a problem. But that controller can accept only which value? Digital value. So here we have to make the analog into digital, analog into digital. The operating voltage of the digital signal processor or DSP controller is 5 volts. FPGA controller operating voltage is 3.3 volts. So if you use digital signal processor means large 5 volt is, we can tell it as logic 1. So this is the way we can provide the Hall effect voltage sensor and current sensor value to the processor. We can give to the processor. Now the processor know the value of voltage and current through our we have to do some calculations. Then we can store the value into register. What is the use of register? Not a resistor. Register. It is used to store 1 bit of information. It is used to store 1 bit of information. Here the ADC, analog to digital converter, in the digital signal processor, ADC is 8-bit ADC. So resolution formula 2 power n. So 2 power 8 will come 256. So we can make the PV panel voltage and current into 256 samples. For every 10 millisecond, I am making the PV panel voltage output into 256 samples. You can see the accuracy of the PV voltage measurement and the PV current measurement. Then the processor will store the value in the register. So already I told the register, it is used to store 1 bit of information. Next step is we have to calculate the error and change in error. So error means current value and change in error means 10 millisecond back how much power error we got, that one. So these two parameters we can store in the registers. So we can compare these two, and the error we can tell this one is crisp input. Crisp input. The shape will not be a triangular or square. It may be any shape. That is the crisp input. Now we have to provide this input to the falsification step. In the falsification step, it will convert the crisp input into triangular signal with the help of some rules. So the membership function here we can use triangular membership function, and the name of the falsification technique is Mamtani, M-A-M-T-A-N-I, Mamtani. We can use 25 rules or 49 rules. That one explained in the next slide. Here we have to choose some rules. If your shape is falsification output is 0 to 100 or 0 to 200, these rules will make into less than 1. Zeros and ones. Your input may be any shape, but the falsification output will be a triangular shape. Why I am suggesting triangular membership function means from this triangular membership function, easily we can get the reference signal. Actually, what is the purpose of your fuzzy controller? Simply it is used to generate the reference signal for PWM generation. So from this triangular reference signal, triangular membership function, we can easily generate the reference signal for PWM generation. That's all. So the falsification step will convert the crisp input into triangular shape. Now our defalsification will convert the 0 to 1 triangular signal into original shape of the crisp input. So falsification will make the high value of error into less than 1. Defalsification will make that value into crisp input. That's all. Now we will get which one? Reference signal. So you can now compare this reference signal with respect to the carrier signal. So if we compare the reference and the carrier, we will get adjustable PWM pulse. So we can provide this PWM pulse to the converter. Once again, we have to measure the voltage and the current. Again, we have to calculate the change in error and the change in error. We have to compare. If error is 0, same duty cycle will go. Otherwise, we have to change the duty cycle. So this is the good flow chart for the fuzzy logic MPPT algorithm. For converter, initially we have to assign the duty cycle. So initial duty cycle of the converter, the safest side is 50% of the duty cycle only. Under 50% of the duty cycle, we will get some output voltage from the converter or output power from the converter. Next, we have to measure again PV voltage and PV current. Now we can get the power by product of voltage and current. We will get the power. Next, we can compare the reference power and the actual power. So we will get the error. Then we can compare the error and previous error. So we will get the change in error. So you can give this error to the falsification. This will make the crisp input into triangular shape. Through inference engine and rule base, we can convert the high value of triangular signal into less than 1. Again, defalsification step will convert the triangular high value of triangular signal or 0 to 1 triangular signal into crisp input. That is the reference signal. So if we make the reference signal and the carrier signal for comparison, we will get PWM pulse. So you can calculate the once again you have to increase the duty cycle. If we can provide the pulse to the converter, so at one point it will provide 96 or 97% efficiency. But you can think here, what is the drawback of the fuzzy logic? It's having external memory. External memory means it's like a calculator. It's like a calculator. You have to type some values. It will work. Then you will get the output value. Then you have to store in your mind. So this is the drawback of the fuzzy logic algorithm. It's a time-consuming process. In the rule-based engine, So the error, if we compare the error and the change in error, the error may be 0 or positive small value or positive big value or positive medium value. Similarly, 0, negative small, negative medium or negative big. With this, we can create the condition. So for example, if we let us take our error and change in error as 0, positive small, positive medium, positive big, and negative small, negative medium, and negative big. Similarly, change in error also 7 condition means 7 cross 7, 49 rules we have to use it. 49 rules we have to use it. If you use only 0, positive small, positive big, similarly negative small, negative big. So 5 cross 5, 25 rules we can use it. So number of rules are high. In fuzzy logic algorithm, if you use instead of 25 rules, if you go with 49 rules, it can give better efficiency. But if you increase the rules, number of rules means already I told we can implement this process in the digital processor, digital signal processor. So it will utilize huge amount of memory. It needs more number of registers. So what will happen? Final result, heat of the processor will high. That means power consumption will be high. So this is the drawback of the fuzzy logic algorithm. So we have to go for artificial neural network controller. Next MPPT algorithm or next controller is the ANN, artificial neural network topology. In artificial neural network topology, it's like our internal brain. It's like our internal brain. So compared to fuzzy, ANN is okay. But in ANN also here we have to use huge number of hidden layers. Then only we will get good results. So fuzzy logic is like a calculator. ANN is like a brain. So if we combine these two, we will get ANFIS, neuro fuzzy logic algorithm. ANFIS. From ANN we are taking AN. From fuzzy, FIS, we are taking FIS. ANFIS, that's all. The combination of fuzzy and ANN, we can tell it as neuro fuzzy or ANFIS. Then what will be the advantage of the ANFIS controller? It's having both internal memory as well as external memory. For neuro fuzzy logic algorithm, it needs only 7 rules. 7 rules is enough to give good efficiency. So compared to fuzzy, you can check the neuro fuzzy. For fuzzy, 49 rules are there. For neuro fuzzy, only 7 rules is enough. So power loss of the controller will be very less. So that's why I'm suggesting neuro fuzzy is the best MPPT intelligent controller for to control the converter. It may be in under MPPT or closed loop. Neuro fuzzy logic is the best one. But for PHT work, it is not enough. So you can go with cascaded fuzzy logic controller, type 2 fuzzy logic controller, or you can cascade fuzzy logic as well as neuro fuzzy logic controller. So you can go with the hybrid techniques. So you will get good efficiency as well as good tracking power. So with this, I am concluding neuro fuzzy logic controller is the best MPPT. Sorry, neuro fuzzy logic algorithm is the best MPPT in under intelligent control technique or intelligent MPPT techniques. The next one is proposed grid-tied PV-based charging station as well as our home UPS applications. In the first system, I didn't connected battery, correct? But in this system, you can see I have connected battery. The PV panel output voltage we can provide to the bidirectional DC to DC converter. Here I am suggesting bidirectional DC to DC converter. Why means during daytime, if you use PV panel, you will get the output, and we can store the energy in the battery, and we can provide this power, battery power under night time, but it can give only for 4 hours or 6 hours. That is not enough. But if you use a bidirectional DC to DC converter during night time also, the battery will get energized. So without the PV system also we can provide power to the grid as well as for EV, electric vehicles. We can store the power in the battery as well as you can charge directly. You can charge the EV battery directly in the bidirectional DC to DC converter input side. So in under daytime from PV system with one circuit will come. That means unidirectional partial shading effect controller. So that is a big converter. So if you use this converter, only unidirectional flow will come. So with this converter, we can charge the battery, or we have to use one diode. That diode will block the return current, so it will come safer side. So why bidirectional converter means during daytime already I have told from PV system. Let us take I am connecting 5 number of solar panel in series, so 60 volt will come, correct? So in this battery I will connect number of batteries 5. So if we connect 5 batteries in series, that voltage is also 60 only. So you can take 48 volt EV battery or 60 volt battery, it can store, not a problem. Now we are providing 60 volt to the bidirectional DC to DC converter. That converter will boost the 60 volt or 48 volt into 300 volt. Now we can give this 300 voltage to the single phase inverter, and this inverter will convert the DC into AC through LC filter. We can give this value to grid. So here, so already I told now for grid connected application, controller is the best one. So here we can compare the reference and the actual. This error is given to PI or fuzzy or ANN or ANFIS or any optimized PI controllers. So it can provide a reference signal. By comparing the carrier signal, we will get a PWM pulse. So we can give this pulse to the bidirectional DC to DC converter. If you set reference voltage as 300 volt during daytime, I am telling. So reference is 300 volt, actual voltage is the bidirectional DC to DC converter output. If we compare these two, error will come, it will make the PWM pulse. The converter will work under boost mode. During night time, from grid we can give the power to the single phase inverter, and the inverter will work under rectification mode. So this will convert the AC into DC. We can store this DC voltage in the DC link capacitor. So what is meant by DC link capacitor? The capacitor which is connected in between the DC and AC. In between DC and AC, we can tell it as DC link capacitor. So if we connect one DC link capacitor, here we will get a 300 voltage. So the bidirectional DC to DC converter output is 300. For battery charging during night time, I am telling, for battery charging, for EV battery charging, our reference voltage will be 48 volt or 600 volt. So the converter will work under buck mode. What will happen? The 300 voltage will come as 48 volt or 60 volt. So you can give this to the EV battery or normal battery. So this is the working of the bidirectional DC to DC converter. Here, if you use only unidirectional converter, DC to DC converter means you have to use another one bidirectional converter also. That means the normal unidirectional converter, use normal boost converter. For battery charging as well as discharging purpose, you have to use another one bidirectional converter. But with this system, no need to use unidirectional converter. The single converter is enough. But one question will come: how the DC to DC converter, how the single switch, how it will work as buck as well as boost? This bidirectional. Here we have to club two converter, either buck boost or Sebic low or Sebic theta. That means input current should be continuous in the input side of the converter, and output side output current must be continuous. In Sebic converter, single-ended primary inductor converter as well as boost converter, input current is continuous. But in the Cuck converter, Lu converter, Theta converter, Landsman converter, output current is continuous. So if you merge these two converters, two switches will come, two inductors will come, two capacitors will come. So different number of switches and inductors will work for charging time, and another set will work for discharging time. So those problems will not come. Switching losses, switching stress problems will not come in the bidirectional DC to DC converter. It will come, but it will be in allowable limit only. Okay, in this system, we have to measure the battery voltage as well as battery current or battery SOC. I told you now this system, it can be useful for microgrid, smart grid, electric vehicle as well as home UPS application. This is the general block diagram. So you can do more than 1000 PST with this block diagram. You can change the bidirectional, different types converters, different types of controller, different types of grid synchronization. Minimum 1000 PST works you can take from this block diagram. But the main thing is we have to monitor the battery. For monitoring the battery, so many techniques are there. Some of them will use basic Kalman filter for SOC monitoring, and some of them will use Arduino-based IoT techniques, and some of them will use machine learning or deep learning techniques. So I will explain one by one. So from this PV system, okay, so this is the first technique, IoT-based battery monitoring system. So from the one battery, we have to connect the three sensors. First one is temperature sensor, current sensor, and voltage sensor. So the temperature sensor can monitor the temperature, current sensor, voltage sensor. So what is sensor? So the purpose of sensor, it is used to monitor some parameter. But what is sensor means, it will convert the physical quantity into electrical quantity. That is the definition for sensor. So if we monitor the temperature as well as current and voltage, this will be analog value. So with this one Arduino controller, so the Arduino controller will convert the analog into digital. Here also we have to do some mathematical calculation for current measurement and voltage measurement, then temperature measurement, some analog to digital conversions we have to do. So from this conversion, we can display the battery voltage, battery current or temperature in the LCD display, liquid crystal display. That is the first step. But recent days we are going with IoT, Internet of Things. We can monitor or we can control all the electrical and electronics devices with the help of internet. Website, that's all. So for this, we need one Wi-Fi module. So Wi-Fi module means in all your PC as well as mobile. So networking module is there, transmitter as well as receiver, modem, modulator and demodulator. This modem can transmit as well as receive the signal. So this node MCU module having IP address. If you write the same IP address in the website, if you link the website IP address as well as node MCU IP address, this comes under parallel communication. So if you give any data to the node MCU module, same value you can see it in the IoT web page, Internet of Things page. In website we can monitor. So in this system, so if your battery gets overcharging or over temperature, if problems is there means, here we have to connect the PV as well as converter into the battery with the help of one electronic relay. So what is relay? Relay is a electronically operating switch. Relay is electronically operating switch. So the Arduino controller can monitor the predefined value of the temperature, predefined value of the current voltage of the battery. If it exceeds, what will happen? Immediately Arduino controller will alert the relay circuit, relay driver circuit. So the driver circuit will make the output of the Arduino controller will be 5 volt, but the relay will work under 12 volt family, 12 volt TTL family. So the relay driver will amplify the 5 volt pulse into 12 volt pulse. If we give this to the relay, immediately it will cut off the battery. It will cut out the battery. So the battery comes to safer side, or our load comes to safer side. So monitoring, both controlling, we can do it in the IoT side. But see, it will not give efficient results. Definitely it will not give efficient results. The sensor based. Here only we are doing analog to digital conversion, that's all. Here also there is no memory. there is no advanced intelligent techniques. So we have to go with some artificial intelligent techniques. If you combine IoT and artificial intelligence AI technique, it will give 99.99% efficiency in the battery monitoring system. So here we have to club the deep learning as well as machine learning technique into IoT. So we will get good result. This is also PhD work only. If we go with the different deep learning as well as machine learning and use IoT techniques with the Raspberry Pi processor or FPGA controller, this is also good research work. So you all have to know about the battery. So I am directly going to the battery converters. So this is the bidirectional basic DC to DC buck boost converter. So we can give the lithium ion battery output voltage. For EV application, lithium ion is the best battery. Here you can see two switches are there. Correct? Switch S1 will work for boost mode. Switch S2 will work for buck mode. I will explain this circuit also. So this is one DC source and this is also DC source. During daytime or during the availability of the PV power, this is the source. Correct? That means right side. This is the source. Next to the DC source, switch is there. So this will work in buck mode, buck converter. So this is the bidirectional buck boost converter. That's why I'm telling next to the DC source which is there. That means discontinuous conduction mode. We can tell it as buck converter. Here you can see after charging the battery, this is the DC source. Next to the DC source, inductor is there and the switch is connected in parallel. So this switch will work under boost mode. So this is the combination of buck converter and boost converter. So during the availability of the PV power, it will work under boost mode. During night time, this will work under buck mode. What is the drawback of the converter? Simply we can tell. Voltage gain 1:1.5. I told the 48 volt into 300. It's not possible with this converter. So if you give 48 volt, you can get around 72 volt. That's all. So here you have to increase the battery. Around if you use 200 volt PV panel as well as 200 volt battery, then only we can get 300 volt. So we have to go with some high gain converters. In the battery converter, there are two types. First one is non-isolated bidirectional DC to DC converters, and the second one is the isolated DC to DC converter. What is the difference between non-isolated and isolated? Non-isolated, there is no isolation transformer. Isolated, this isolation transformer will come. Then what is the difference between the normal transformer and isolation transformer? Means in normal transformer you can do step up as well as step down process. This one is a ratio transformer, 1:1 transformer. For normal transformer you cannot give DC voltages input. For this isolation transformer we cannot give. Here also you cannot give normal DC, but you can give high frequency DC. Switched output waveform you can do. That's why I have connected one MOSFET here. So compared to IGBT, MOSFET is the high frequency device. So IGBT maximum operating frequency of the IGBT is 20 kilohertz. But MOSFET we can work up to 150 megahertz. So if we give this DC voltage to the MOSFET, it will make into 150 megahertz. Depends on our application. You can choose 20 kilohertz or 50 kilohertz or 100 kilohertz or 1 megahertz. Depends on your application and the coil. You can choose the switching frequency of the MOSFET. So you will get different variation. Now we can provide this output to the isolation transformer. The isolation transformer will convert the DC into AC. The output of the transformer will be AC only. But here there is no interlinking connection between the primary coil and the secondary coil. But in isolated converter, the DC source and the batteries are connected in series or parallel. It's interlinked. It's connected between the DC source as well as battery through wired. But this is wireless connection. What is the advantage in a non-isolated converter? Fault current will flow. But in this isolated converter, we can eliminate the fault current. Then output side, we have to use diode as well as MOSFET. So it can work as a synchronous rectifier. So we can give this to the battery as well as source. So this is the difference between non-isolated converter and the isolated converter. So in the non-isolated converter, so how to control the boost as well as buck means. So with this circuit diagram, I will explain. So from PV system, we have to track the maximum power, correct? So BPV and IPV, I will use a fuzzy logic or neuropathy or ANN controller. This will provide a reference signal and we can create the PWM pulse. If we give this PWM pulse to the boost converter, we know it tracks maximum power from the PV system during daytime. And we can give this power to the inverter or load. During night time, here we have to assign the reference value because MPPT will not work in the night time. Here we have to assign the reference voltage for battery system and the actual value of the battery voltage. If we compare these two, we will get error. Here you can use PI, PID, fuzzy, ANN or ANFIS or neuropathy or optimized PA. Any controller you can use it. Then the controller output we have to compare with the carrier signal. Here we will get a PWM pulse. So the MPPT or optimization technique you can use it for used to control the DC to DC converter. That means boost mode. Here in the right side for buck mode, you have to assign the reference value depends on the battery voltage. 12 volt battery or 48 volt or 60 volt, anything. So you have to assign the battery voltage, that's all. So next converter. How to integrate the two converters, SEPIC and CETA. So I told SEPIC converter comes under continuous conduction mode. Zeta converter comes under discontinuous conduction mode. Here you can see in the input side, next to the DC source, one inductor is there. In load side also you can check. So after the inductor, load is there, correct? So input current also continuous, output current also continuous. The voltage gain of the SEPIC converter is 1:8. And the voltage gain of the Zeta converter is 8:1 or 4:1. So depends on the inductor, we can make it. So I told you now that boost converter, bidirectional buck boost converter, voltage gain of the converter is 1:1.5 only. During boost mode, 1:1.5. During buck mode, 1:1.5 into 1. But here, 1:8 and 8:1. So you can reduce the number of solar panels as well as reduce number of batteries. So that is the advantage of high gain converter. So if you integrate the SEPIC loop or SEPIC Landsman, so you will get different converter topologies. The next one is SOC monitoring. State of charge monitoring. So this SOC monitoring is it's not directly possible to measure in the IoT system. So through some Kalman filters, through some intelligent techniques, we can measure the SOC. So what is SOC? State of charge. So battery means it will store the charge, correct? So electrochemical device, it can store the energy into some chemical form. That's all. If your energy is 100%, then SOC is also 100%. If energy, that means product of voltage, current and time. The product of voltage, current and time. If battery voltage is 0, our SOC also 0. If battery voltage is 12 volt and ampere 100 amps or 200 amps, it depends on the battery, 100 AH or 200 AH. If your current and voltage both are maximum means we will get SOC as maximum. So with this calculation, we can get the SOC. So, but manual calculation is not correct. So we are going with some intelligent controllers. For SOC monitoring also, from this voltage, current and time only we can get the state of charge. Correct. So this PI controller or facility controller or ANFIS or ANN also can estimate the state of charge. This is intelligent control technique. Here also some problems are there. In the physiologic mode, I told number of rules will come. In neurophysiologic, internal memory and external memory will come. So compared to Kalman filter, fuzzy, ANFIS, ANN is good, but my suggestion is artificial intelligence only. So we have to go with artificial intelligence, memory based one. So these are the old techniques to calculate the SOC. From lithium ion battery, we have to go for multi-neural networks. So through this multi-neural network, we can estimate the state of charge. So how it is possible means we have to measure the voltage and current. We have to train the data. From this trained data, you can get the test output. So if your battery voltage is 0, SOC is 0. If your battery voltage is 12 volt, it can give 100 volt. That means 100% of SOC. SOC is 100%. Similarly, with respect to current also, we can get the state of charge. This method also good one only. But the drawback, it will take more time. So, and it is not a good efficient. So we have to go with artificial intelligence. So what is the difference between normal brain and artificial intelligence? So artificial brain means the normal brain having 3 main lobes. This lobe having some liquids, that means it's occupied the space from the brain. So you cannot use complete our human brain to store the data. That's why we are moving to one artificial brain. So if you use one artificial brain means you can use 100% storage. It does not having any emotional or feeling or thinking. Correct? But this AI will not do anything. So it will give only storage, and it will give the output data. So compared to the human brain, artificial intelligence is best one with this, due to this reason only. Emotional, feelings, thinking, these problems. So what is the difference between normal learning and machine learning? So example, happy birthday and another one is happy birthday. Correct? If you see deeply, we can get the error easily. But next one you can see in Taylor series and Taylor series, same number of characters, but small mistakes are there. Correct? During the manual calculation, we will allow this error. But in under machine learning or deep learning, once Taylor series is stored in the brain means or memory means, it can compare the test data with respect to the trained data. Here first Taylor series or partial identity is the trained data. Next one is the test data. If test data is wrong means the deep learning or machine learning will alert. It will give alert. So it will give the output as 1. So we can find some error is there. So this is the way in battery SOC monitoring. So in trained data, for example, 80%. So with this voltage and current, if your SOC is 80%, the test data, normal neural network or normal SPM or under normal fuzzy logic, it can give 80%. But this deep learning or machine learning will tell that is not 80%. Only 78% is there. 2% drop in the battery. Like that it will tell. That is the difference. Accurate prediction is available in deep learning as well as machine learning. So in the ordinary intelligent controller can give 90% of the result means this machine learning as well as deep learning will give more than 98%. It will give 98% of the accuracy in the SOC monitoring. So this is the common structure of artificial neural network. So ANN as well as CNN, convolutional neural network, or a probabilistic neural network, or radial basis function neural network. It's having 3 layers: main input layer, hidden layer, and output layer. Input layer, hidden layer, and output layer. Number of hidden layers 2 means that one is artificial neural network. If number of hidden layers are 3 means we can tell it as RNN, recurrent neural network. If number of hidden layers 4 means that ones we can tell it as CNN, convolutional neural network. So compared to ANN, CNN will provide best result for SOC monitoring. So this is the deep learning neural network. That means multiple hidden layers. If number of hidden layers are 3 means I told the RNN, recurrent neural network. If number of hidden layers 4 means convolutional neural network. So this is the CNN model of the CNN. In the convolutional neural network, so many layers are there. Convolutional layer, pooling layer, fully connected layers. So many layers are there. So I will explain the digital signal processing concept here. So we have studied digital signal processing and mathematics 3. So this is the basic for SOC monitoring. How to get the trained data, first one. So you can get the voltage, current and time from the battery. VIT, voltage, current and time, because energy is the product of voltage, current and time. That's why we are measuring voltage, current and time. So how to get the trained data means, let us take 100 Ah battery. So 100 Ah battery means voltage 12 volts, amps 100 and time 1 hour. Correct? So this is the maximum value of the data. First step of the signal processing is pre-processing. First step is pre-processing. Under pre-processing, we have to remove the noises, or we have to set the limit. We have to set the limit. Voltage means maximum 12 volt only. Current means 100 only. Time means 1 hour only. So this is the way we have to assign the pre-processing data limit, time limit. And another one is pre-processing means noise reduction. So in SOC or in voltage and current, some unwanted oscillations are there means the filters will reduce the problem. So under SOC estimation, first we have to select one good filter. So different types of filters are low pass filter, high pass filter, band pass filter and band reject filter. If we use only low pass filter, it can give only x-axis value. If you use high pass filter, it will give y-axis value. Here we have to assign both the x-axis time and voltage, time and current. So here we have to assign band pass filter. So band pass filter means combination of low pass filter as well as high pass filter only. So this can provide the maximum voltage, maximum current with respect to time. So this is the function of pre-processing. Under pre-processing, mainly two works. We have to assign the range and we have to reduce the noises. Next step is segmentation. So what is segmentation means? We have to convert the continuous images or continuous signals into discrete. That means we have to make it into samples. So for that we know FFT. We have studied FFT, fast Fourier transform. That is the old technique. In M3 we have studied Fourier series as well as Fourier transform. So we know the formula f of s is equal to f naught plus summation of n is equal to 1 to infinity f of x cos nx dx plus summation of n is equal to 1 to infinity sin nx dx. Under f naught, you will get 0 parameters of the battery. If battery voltage and current keeps on increasing means we will get the parameter from sinusoidal transform, sine transform, because sine 0, 0, sine 90, 1. So if you use sine transform, you will get the increasing voltage and current data with respect to time. If you use cosine transform, we can get reduction process. So anyhow, this FFT will make voltage, current with respect to time into 256 samples. Why here we are making into 256 samples means For every 10 millisecond, already I have told we will measure the voltage and current, correct? So here the digital signal processor ADC value is 8-bit only. So resolution formula is 2 power n. So 2 power 8 will come to 56. That is the reason why we are making into 256 samples. But here FFT is very old. DWT also old. Discrete wavelet transform. Hilbert transform also old. So you can go with DCT, DOST, discrete cosine transform, discrete orthogonal Stockwell transform, or hybrid transforms, as well as neural network based segmentation, deep learning based segmentation. You can use it. What is the difference between Fourier transform based and the neural network based? Means Fourier transform will convert the data into samples, but it cannot store the data. But if you go with the neural network segmentation, it can convert and it will store the data. That is the difference between the normal segmentation and the neural network segmentation. Anyhow, from the segmentation, what are the parameters we got? 256 samples with respect to their amplitude, correct? So we have completed 2 steps, pre-processing and segmentation. Third step is future extraction. That is the main thing. So future extraction means GLCM or GRCM or SIFT. So many techniques are there. Under this GLCM future extraction, 12 features will come. Texture features, color, contrast, energy, entropy, deviation, standard deviation, like that. 12 features will come. Let us take only 2 features. First one is deviation. Second one is energy. Energy means y-axis parameter. Deviation means x-axis parameter. If your SOC is good, means you will get all the values in the sample output. That means if your SOC is 100% means all the 256 samples having value as 1 volt. Correct? If your SOC is 50% means what is the value? 0.5. If your SOC is 75%, the value is 0.75. So with these features, we can get energy. Next one, deviation and standard deviation. Deviation means first sample and second sample. Difference between the second and the first sample. If the time is, we will get one time. We have to consider this time with the next. We have to compare another 2 samples now. Now we have to compare these 2 differences. If difference is 0, not a problem. If it is having difference means battery getting some problems. Correct? Fault current it is there in the battery. So these features will give amplitude and time. So we can estimate the trained data. We have calculated for 100% how much value in the segmented output. So this is trained data. Next one, test data. What is test data means? Our actual input. Actual input means, for example, now I am measuring the voltage and the current from the battery. With respect to time, once again I will calculate it. Then pre-processing step. So I will make the limitation and I will reduce the noises. Then this is given to the segmentation. Same, this will convert into 256 samples and I will get the amplitude. Again, I will take the features from the test data. So I have to compare the trained data and the test data. So 256 samples are available in the trained data. Same 256 samples are available in the test data. If we compare these 2 with the help of neural network, if you use normal neural network, it's having only 2 layers. But if you go with convolutional neural network, it's having 4 hidden layers. So compared to normal neural network, this CNN will check for 4 times. That is the difference. So this CNN will give accurate value. This will compare the trained data, first sample of the trained data and the first sample of the test data. If your test data matches with 100% or 99 or 98, 97, the output will come. So how much SOC is available in the battery? Now we can combine the deep learning as well as machine learning with IoT. So you can check it now. How means for Arduino controller, we will give the voltage and current with the help of sensors. The operating frequency of the Arduino controller or Node MCU controller is only 16 megahertz. 16 megahertz. So if we calculate the time, it will come under microseconds. So the processing time is microseconds only. But if we use Raspberry Pi processor or FPGA controller, if we go with the FPGA means its operating frequency is 150 megahertz. So it comes under 10 power minus 10 seconds, VLSI. So the processing time is compared to normal Arduino microcontroller. In this FPGA controller is very, very good.
Sir, Kevin sir.
Sir?
Kevin sir.
Tell me, sir.
Sir, can we have a break, sir?
Okay, sir, sir.
Yes, sir, you can continue.
Okay. So the convolutional neural network, we will compare the trained data and test data. So finally, we will get the state of charge. So with FPGA controller, field programmable gate array. So I told its operating frequency will come 150 megahertz. So compared to the Arduino controller or PIC controllers, it can provide good interfacing with the neural networks and IoT. So this is the main flow of the convolutional neural network. So initially we have to assign the trained data. So in trained data, I told you pre-processing, segmentation, future extraction, finally classification. So it will minimize the error. That means it will minimize the error between the trained data and the test data. So this will give accurate result of the SOC, state of charge. So I will suggest some of the deep learning techniques. You can use CNN, convolutional neural network. If it is your PhD work means you can go with the type 2 CNN or PNN, probabilistic neural network. So the difference between convolutional neural network and the probabilistic neural network is convolutional neural network, it needs more number of trained data. But for PNN, only one trained data is enough. So number of trained data is very less compared to CNN. And another advantage, memory. So CNN require huge amount of registers, but this PNN need only 256 registers for trained data and 256 registers for test data. So machine learning technique. So what is the difference between deep learning and machine learning technique means if you can implement the neural network techniques in processors, signal processor or Raspberry Pi or FPGA controller, we can tell that one is machine learning. So logistics, SVM classifiers, regression, linear regression methods. So many methods are there. So for PhD works, you can use deep learning methods, type 2 CNR or type 2 PNN or RBFNN, radial basis function neural networks, you can use it. Okay, next, I will suggest the different converters and different control techniques for battery conversion, battery monitoring, and bidirectional converter controlling. So for bidirectional DC to DC converter, in input side, you can choose boost converter as well as SEBI converter. For boost and SEBI converter, input current is continuous. In the output side, you can choose any discontinuous conduction mode converters. And best control technique is cascaded fuzzy or cascaded ANFIS or cascaded AN. Later, you can cascade fuzzy ANFIS, fuzzy AN. So this will give good result. Or optimized GW Grey Wolf optimization, PSO, or you can use hybrid optimization, GW PSO or Lion Cat. Like the way you can take the optimization techniques. Next, grid side controlling technique, you can use PI controller. That is enough. For grid synchronization, if you use fuzzy logic controller or neural network controller, what will be the problem means response time between the inverter to grid connection should be very less. If you use fuzzy logic controller, it will give good result, but it will take time. So it consuming more time compared to the PI controller. So under this time extension, total harmonic distortion or power quality issues will be very high in the inverter output. So grid side PI controller is enough. Next, I am suggesting EV motor, electric vehicle motor. So many types of motors are there, DC motors and AC motor. In DC motor, DC shunt motor, DC series motor, DC compound motors are there. But in DC motor, the drawback, both armature and field having windings. Also, it needs one mechanical commutator. So without the mechanical commutator, the machine will not run. All the DC machines are like the way only. Then we can go with the AC motor. So if you take induction motor, maximum RPM, you will get 1415 RPM for 4-pole machine because of the slip problem. And this induction motor also having windings in the stator and rotor. Both these windings give power losses and efficiency also we will get very less only. So we have to go with the permanent magnet based motors. We combine DC shunt motor and the induction motor stator, we will get brushless DC motor, BLDC motor or PMSM motor or reluctance motors, RSM, reluctance synchronous motor. So we can go with some special electrical machines, BLDC, PMSM or this reluctance synchronous motor. So PMSM motor, the control technique is very complex. You have to use Park transformation or Clark transformation. But compared to the PMSM motor, BLDC motor cost also very less, controlling also very easy. You can do both sensorless or sensored operation we can do. So for EV application, if you go with the BLDC motor or PMSM motor, PV panel and battery requirement is very, very low compared to the normal induction motor as well as DC shunt motor. And another one, controller selection. Controller means hardware. So the main first microcontroller we know 8051. The first version of the microcontroller is 8051. Still we are studying in our syllabus 8051 only. The 8051 operating frequency is 10 megahertz and operating voltage is 5 volt. Why the operating voltage is 5 means it comes under the IC comes under TTL family, transistor logic family. That's why its operating voltage is 5 volt. And operating frequency is 10 megahertz. You have to use more number of instruction sets, opcodes. So digital controlling, it's not suitable with this controller. So we have to go for next PIC controller, PIC. In the PIC controller, you can create only 2 PWM pulses, but inverter we need 4 PWM pulses, correct, for single phase inverter. So next option is DSP controller, digital signal peripheral interface controller, DSP controller. Under this controller, 33 families are there, but still we are studying 8051 in our syllabus. So you can choose DSP controller or digital signal processor. So this DSP controller, operating frequency of the DSP controller is 40 megahertz and digital signal processor operating frequency also 40 megahertz. Next one is FPGA controller. Already I have told FPGA controller comes under CMOS family, complementary MOSFET family. So its operating voltage is 3.3 volt only, and operating frequency you can vary up to 150 megahertz. And another difference between the DSP and the FPGA family is, with the DSP controller you can control only 6 devices, either 6 MOSFET or 6 IGBT only. But if you use FPGA controller, you can control minimum 100 number of devices. So minimum 100 number of IGBTs as well as MOSFET we can control it. So for high power application, and if you use hybrid converters, the best option is FPGA controller only. Response time is very good. Power loss also very less in the FPGA controller compared to these controllers. So I told the operating voltage of the DSP controller or DSP is 5 volt and the FPGA controller operating voltage is 3.3 volt. But in order to drive the MOSFET or IGBT, this 3.3 volt or this 5 volt PWM is not enough. So we have to amplify the 3.3 or 5 volt PWM into 15 volt PWM pulse. So then only the MOSFET or IGBT will turn on. So here the driver circuit will provide two works. First one is amplification. Second one is isolation. What is the use of isolation here means the DC converter, inverter and all are power circuit. But the DSP controller or FPGA controller comes under control circuit. So we have to isolate both the control circuit or power circuit. Otherwise what will be the problem means, in the control circuit, maximum operating voltage is 5, but in power circuit, it may be 230, 415 or 11 kV. If any current returns from the power circuit to the control circuit means immediately control circuit will burn. So to overcome the problem, we have to go for isolation. So the driver circuit will give both amplification and isolation. How it is possible means, the driver circuit is the combination of optocoupler, that means combination of photodiode and phototransistor. Photodiode means LED, phototransistor means normal BJT. So we can give 5 volt PWM into the LED through one resistor, because LED is the current control device. So if we give this 5 volt PWM to the LED will glow during on time and it will off during the off time. The same light will be a phase signal to the transistor. So for transistor, we have to give 15 volt to the collector and emitter. So the transistor will amplify the light signal into 15 volt PWM. So now we can give the 15 volt PWM to the inverter or converter. Here you can think there is no direct connection between the photodiode and phototransistor. This is isolation. We are separating the transistor and photodiode. So the driver circuit did two works: 5 volt to 15 volt conversion and isolation. So the isolation, with this isolation circuit, the problem will not come. And the switching losses. Next, we have to consider the switching losses. We use normal buck as well as boost converter. We have to maintain 90% duty cycle. So switching losses or switching stress will increase. But if you go with the high gain converters, 55% or 60% duty cycle is enough. So the lifetime of the converter and inverter will be more compared to the normal basic buck boost converters. So the best battery, lithium ion battery, you can use for the EV application, and the controller side, that means for hardware side, I am suggesting FPGA controller, field programmable gate array. So and the PWM technique, if inverter, 3-phase inverter means you can use SEPWM, space sector PWM, or modified space sector PWM. For current controlling, hysteresis current controller is the best one to do current harmonics mitigation. And the driver circuit IC name is TLP250. Up to for 100 watts power, you can use MOSFET. If you increase the power from 100 watts to 200 or more than 1000, IGBT is the best option. So if you have any, you can ask the doubts.
Any queries? So if anybody working in power electronics control to renewable energy system, you can ask any questions to Kevin sir. He is working in that area. So if you need any doubt, you can ask it now itself. Even it is not related to this session.
Good evening, sir. Am I audible?
Yes, sir. Tell me, sir.
Yeah, sir. Good evening, sir. Actually, as you told that one, the photodiode, photo transistors we are going to use for protecting the system.
Yes, sir.
So, the transistor, I'm getting that into that because input and output we are going to get it. That LED you told that on photodiode you are going to utilize. How come it will be there, sir? Actually.
Sir, actually, in olden days, we are using photodiode and photo transistor. But in recent day, that driver circuit I told na TLP 250. So we no need to use this photodiode and photo transistor. Simply, we can use this TLP 250 IC.
Okay. So one more thing is that, sir, that
Tell me, sir.
DSP processor and FPGA processor you are telling that one.
Yes, sir.
Frequency will be around 150 megahertz, just like this. But the transition we can get it very faster as point of view you are talking that one. So any application we can utilize which place, sir? Exactly.
Application means you are asking FPGA, sir.
Yeah, yes, sir.
For EV, sir, for entire system, converter controlling, inverter controlling, or SOC monitoring, you can do with this FPGA controller. If you use a DSP controller or DSP controller means you have to use DSP plus Arduino. But if you use FPGA controller, no need to use separate controllers.
Okay. Here also we can DSP means around 6, as you told that one, 6
kWm, sir.
We can utilize that one, but it will be we can utilize around more
100,
than
100 pulses we can.
We can change it. Okay. Thank you, sir. And whether we are going to utilize for any battery set, just like the charging and discharging section in the FPGA, sir, or anywhere? Exactly.
For that also we can do it, sir. SOC monitoring through some machine learning techniques you can implement it. After that, through relay you can control the battery as well as solar panel also.
Okay. Thank you, sir. Thank you.
Thank you.
Sir, one question from a participant. Sir, can you tell me the difference between Zeta, SEPIC, Lu, and CHU converters?
Sure, sir. Actually, Zeta converter, the voltage gain of the Zeta converter is 1:4 only. SEPIC converter, and in Zeta converter, input current is discontinuous and output current is continuous. In Zeta converter, the inductor is normal type inductor, but in SEPIC converter, single-ended primary. The inductor is transformer based inductor. So the isolation problem will not come in the SEPIC converter, but in Zeta converter that will come. The voltage gain of the SEPIC converter is 1:8. Then Lu converter. In Lu converter, so many types are there: positive lift, negative lift, re-lift, super lift. So lot of techniques are there. There also we can choose either input current continuous type or output current continuous type. So in Lu converter also the inductor is transformer based inductor only. But compared to SEPIC converter, the Lu converter gain is high. So practically you can take up to 1:12 ratio. Any other questions?
Sir.
Yes,
Sir,
sir.
relating to this work, if you are going to find any hardware security purpose, how to, and this is not related to maybe, so that I want to know something about that. Hardware security related to that, just like chip we are designing and we are going to find this, some fault or some manipulations will be there. Similarly, in electrical appliances, whatever they are, any hardware security purpose, we can utilize the here anything, sir?
For hardware security purposes means what you are asking, sir?
Actually, just like we know that one some design you are going to make it, and that design is going to be give this output. But exactly whatever the design we plan that one, due to this some malfunction in the circuit itself, we are getting this some distortion. That is your fault. Something we can talk about that, just like this.
Actually, we can identify the fault with this comparison, sir. Trained data and test data comparison, we can do it. But there also we have to use image processing technique only. Image processing or signal processing technique. You are telling now there's some fault.
Yeah.
So we have to train the fault and we can compare with the test data. If any error is there, our controller can alert the system.
Oh, after getting that output only, we can able to identify.
Yes, sir. Because we have to give the test data only now. After getting the test data only, it will give the result.
Reference will be there, then only we can modify.
Yeah, we will modify it, sir.
Okay. But to which place actually any fault or anything you to identify? Just like yesterday sessions are told that on the fault session. So
Okay,
to identify in our circuit diagram, just like this, you are going to take it. Which place we can get any distortion? Or
that also we can calculate. How means, sir? For example, if you design one boost converter means you have to train the data for input current, diode current, switch current, then load current, minimum and maximum limit. Okay, well, sir. So you will get one shape, correct? That is trained data.
Yeah.
Again, you have to compare the test data. So through AI only you will get the solution.
Okay.
But you are asking, this is biggest work, sir. Right now it's not available in the Google Apps.
Now, relating my work a little bit, I want to do that one inside this, so that's a little bit I need. So any help I can call you, sir. No, thank you.
Sure, sir. I will send my number. You can
thank you, sir. Thank you.
Okay, sir.
Good evening, sir.
Good evening, ma'am.
Sir, my question is, if I plan for some DC microgrid or DC microgrid, if I am incorporating my PV with PV machine learning as well as a converter, what kind of microprocessor will be cheap and best, sir?
Microprocessor is not good, ma'am. Microcontroller you can use it.
Okay.
DS PEC 304011 controller.
Okay, that is best.
Yes, ma'am. The controller cost will come only 500 rupees. Overall board will come around 3,500.
How about will it cope up for this deep learning algorithm, sir?
Ma'am, once again, please tell me.
Will this controller will be applicable and cope up with this?
No, ma'am. For that, you have to use FPGA's pattern 6E controller.
Okay, especially for deep learning, we have to try for that, and then for converter, you are telling like this controller will be good.
Yeah, yes, ma'am. Actually, if you use Raspberry Pi means it does not having flash memory. If once you cut the power supply means again you have to dump the program. But this FPGA controller having flash memory, so it can store the program. So no need to again and again program it.
So both things cannot be put in a single controller.
In FPGA controller, you can do both. You can control the converter as well as that control technique.
Okay, FPGA.
Okay.
Okay, sir. Okay, sir. Thank you.
Any queries? Sir, if no, we can discuss another 20 minutes, any of the topics, sir.
Okay. Sir, basics or any advanced techniques, sir?
Advanced.
Okay, sir.
Sir, speaker is off. Sorry, mic is off.
So I will explain about one optimization. So how to optimize the PI controller. So for DC to DC converter, I told you now to PI controller. We can use closed loop PI controller. So normally we will control the PI controller with the help of trial and error method. That means Nicholas method. This will give only 80 or 85% of the efficiency and settle. It will create settling time problems. So to overcome these issues, we are going to optimization technique. So among the optimization technique, one of the easiest method is GWO, Gray Wolf optimization method. So how to implement this optimization, Gray Wolf optimization method means, so initially we have to measure the actual voltage of the converter. So DC to DC converter, output voltage we have to measure it. Then we have to set the reference voltage. So if we compare the reference voltage and the actual voltage, we will get error. If we give this error to the optimization technique, that means GW algorithm. Here also we have to assign the memory. So initial value and the current value. So we have to get the reference voltage and the actual voltage. If the error is 0, no need to adjust the KP value and the KA value. That the existing PI controller output is enough to control the converter. But if error is there, in the GW algorithm, we have to assign 3 registers: alpha, beta, gamma. That means volts. We can tell it as wolf. Alpha, beta, gamma. Alpha will give the value for KP. Gamma will give the value for KI, and beta will give the value for KD. That means proportional gain, integral gain, and derivative gain. So we are comparing the reference voltage and the actual voltage. If error is there means, initially we have to assign some KP value and KA value. That means a random value, KP and KA value. Then maximum KP and KA value we have to assign. So in between the minimum value and maximum value, that will give best solution. So here you have to form one objective function. So what is objective function means? Very simple. Our objective we have to make the error to 0. Correct? So V reference minus V actual into Kp into Ki is equal to 0. That means the algorithm with 50 iteration or 100 iteration, it will choose one Kp value and one Ki value that will substitute into the Kp and Ki place. So if you get the data V reference minus V actual into that Kp and Ka value, the error should be 0. If error is 0, this will give the best result, best data, best volts, Kp and Ka value. So we can choose this Kp and Ka value and we can substitute in the, already we have designed, we have fixed some Kp and Ka value. So we have to replace the existing Kp Ka value with this new optimized Kp and Ka value. So we will get DC link voltage error as 0. That means compared to normal conventional PI controller, this GWO will give optimized output. That means in the basic PI controller output, maximum peak overshoot problem will come. Rise time, fall time, settling time problem will come. But in this optimized PI controller, we can reduce this maximum peak overshoot problems. So easily it will get settled. Same GW algorithm we can use for speed control also. There the objective function n reference minus n actual. Reference speed minus actual speed and the error is given to the Kp and Ka value. Here also we have to assign some minimum and maximum Kp Ka. So you will get the optimized parameter. So this is the way we can tune the speed of the motor. So the GW algorithm is the simplest and best optimization technique to control the converter as well as a motor side. Then finally, I will explain about the direct torque control, DTC. In EV, DTC is very best one. I will explain it now. So why we have to go to DTC, direct torque control. So through one auto transformer itself, you can control the motor, but you cannot run the motor with less than 500 RPM. But EV application or low speed application, you can think it. The initial speed of your electric vehicle is 1000 RPM means it is very dangerous. So we have to run the machine with 100 RPM, 200 RPM, 300 RPM. So slightly we have to increase the speed. It is not possible with conventional auto transformer based control or normal voltage source inverter based control because speed is directly proportional to voltage. Through voltage source inverter, power electronics devices, we are controlling the motor speed with respect to inverter output voltage. Here also you cannot control the speed of the motor less than 500 RPM. And power loss is also very high. So because we are indirectly controlling the torque, we are checking the speed and we are measuring about the voltage. If speed is reduced means we are increasing the output voltage to the motor. So what will happen? Speed will increase. Here we are not considering the torque as well as magnetic flux. But we know the reason why the machine is running because of the magnetic torque and the magnetic flux only. So here we have to analyze the magnetic flux and the magnetic torque, that is direct torque control strategy, DTC. So how we can achieve this means, so we can measure the initially through V/F technique, voltage bar frequency control technique. We have to apply some initial voltage to the motor, AC motors. After that, we can measure the three-phase AC voltage and three-phase AC current of the motor. From this AC voltage and AC current, here we have to apply Park transformation, PARK, Park transformation. This Park transformation will convert three-phase parameters into two-phase parameters. For example, IABC, this one make into IAB, IBC, ICA. After that, here we have to apply Clark transformation. This Clark transformation will calculate IDS, IQS, VDS, VQS. That means direct axis voltage, direct axis current. Similarly, quadrature axis voltage and quadrature axis current. So what is direct axis voltage means because of the linear load, some current and voltage will come. That is direct axis parameters. Because of the inductive or non-linear load, some voltage and current will produce, that we can tell it as quadrature axis parameter. So this direct axis parameter will increase the performance of the motor, but this quadrature parameter will decrease the parameter of the motors. Then after that we can apply inverse Clark transformation. This can find I alpha, I beta, V alpha, V beta. Theoretically, we have studied there is no angle between voltage and current under linear load, but definitely it will produce during practical section. So alpha means the angle between the voltage and current with respect to that linear load and non-linear load. Alpha means linear load angle, beta means non-linear load angle. So due to this Park and Clark transformation, we have separated the direct axis parameter and quadrature axis parameter, then direct axis angle and quadrature axis angle. So through these values, you can calculate the magnetic flux and the torque. So this is a reference torque. For how much speed? That means if you want 500 RPM, for 500 RPM, you will get one reference torque and reference flux. Similarly, we can get actual torque with actual speed of the machine. So we will get reference torque and actual torque. If we compare these reference as well as actual torque, so we have to compare with hysteresis torque controller. If you use hysteresis torque controller, you will get a PWM pulse. If you give this PWM pulse to the voltage source inverter, so the inverter can control the motor at 500 RPM. If you assign 200 RPM, the reference torque will produce for 200 RPM and our inverter will make actual torque also for 200 RPM. So in indirect torque control, it's not possible to run the motor less than 500 RPM. But in direct torque control, you can run the motor with less than 100 RPM or 200 RPM. And another one advantage, DC link voltage utilization. For indirect torque control, we have to provide huge amount of DC voltage, but under direct torque control, we need to give only less amount of DC link voltage to the inverter system. So here also, if you apply DTC in the electric vehicle application, so disadvantage, still we can reduce the number of PV panels and the number of batteries. That is the advantage of direct torque control. In brushless DC motor, PLDC motor, sensorless control is okay, but for EV applications, sensorless control is not good because it will take 1 minute time to reach steady state position. But you can think about the 1 minute under real time. So magnetic locking, jerking problem will come in the electric train. So it's very dangerous for passengers. So for EV applications, with the sensor is okay. For water pumping application, sensorless operation also is okay. So for EV, BLDC motor and PMSM motor with the direct torque control means it will provide good result. So you can overcome the drawbacks of the conventional induction motor with this new BLDC and PMSM motors. So if you want any suggestion for your PhD work, you can ask me, I will tell you.
Sir, good evening, sir.
Good evening, ma'am.
Where we have to use incremental conductance algorithm.
Increment for medium power application, incremental conductance algorithm is okay, ma'am. You
What
can
is
use it.
okay?
Hello? Up
Okay,
to 10
sir.
kilowatts range, you can use it, ma'am.
What is the difference between PNO and incremental conductance?
Ma'am, that P&O algorithm and incremental conductance algorithm, the main difference carrier signal and reference signal only. In P&O algorithm, no need to generate the duty cycle. That means we no need to consider the reference signal mainly. But this incremental conductance algorithm, that depends on the error between, that means error and change in error will come in the incremental conductance algorithm. So this incremental conductance algorithm will provide around 85% efficiency up to 10 kilowatts. If you increase the power, in that incremental conductance algorithm will not give good efficiency.
Oh, and for high power applications, what type of algorithm we can
Intelligent
prefer?
controllers, ma'am, fuzzy,
Oh,
ANN, and PIS.
neural net. Okay.
Yeah, neural network.
Okay. What is partial shading conditions?
Ma'am,
Any
partial shading condition means, for example, if you are having 10 solar panel means, while arranging the 10 solar panel, some shading will come with trees or buildings or these solar panels. So then what will happen? We will not get equal output voltage from the different solar panels. That is partial shading. So to overcome the partial shading problem, first one you have to use solar tracker. First one. Otherwise, we have to use SEBI converters, high gain converters.
Oh, DC to DC converters we cannot use, sir?
Yeah, that is SEBI converter I'm telling.
Comes
That is
under the
good
category.
converter. Yeah.
Okay. In this DC to DC converters, we are using that one. So in that buck and boost converters are available. So if combination is preferable or only buck and boost, we can use that one.
Actually, that is SEBIC lose it all are buck boost converters only.
SEBIC and Zeta.
SEBIC, Zeta, Lu, Landsman, all
Oh.
converters are buck boost type only. If your duty cycle is more than 50%, it will work under boost mode. Otherwise, it will be in buck.
Oh. So based on the applications, we can use that any type of
converters.
Okay, sir. Thank you.
Okay.